Hello, College of Algebra, and welcome to Chapter 6. We are working on matrices, and we'll be doing operations with matrices and all kinds of things. The first thing we're going to do, though, is learn how to read a matrix, what rows and columns are, and things like that. So I hope you have notes out. We're in a new section, so let's go. Okay, we're going to talk about augmented matrices. We're going to perform operations with matrices. We're going to do a Gauss-Jordan and a Gauss elimination. Gauss-Jordan is the main one we're going to use. The Gaussian is just how we get there. All right, the first thing we know is a matrix is just a rectangular array, so it's rows and columns. The entry is a number in the matrix, so all of these are entries. Rows are horizontal lines, so these are rows going this direction. And columns go vertically, so columns go this direction. So when we look at this one here, this is a 3 by 4 because we have 3 rows. It's always rows by columns. So it's 3 rows by 4 columns. Now, when we look at this, we have to know where we're at because this is also how we're going to learn how to multiply them. So like this is row 1, column 1. This is row 1, column 2. Here, this here is row 2, column 2. All right, fill in the rest of yours. All right, you should have had row 3, column 1, and over here, row 4. It did not print well, did it? Column 3. I hope you did well on that. All right, now I want you to pause and fill this in. The name of this matrix is D. All matrices have capital letters for their name. The size is a 3 by 2 because it's 3 rows by 2 columns. The entry in row 2, column 1. So row 2, column 1 is 4. The entry in row 1, column 2, row 1, column 2 is -2. Now, hopefully we can read matrices, okay, so we can keep going. Okay, we use matrices for a lot of things, but a lot of them is solving equations, so we don't have to do triple elimination and things like that. So first you got to learn how to write all of these in. So the first thing you do is when you have your equations, they must be set up in order. So like this one here is x, y, z equals the numbers. All of the entries have to be set up that direction. So we have x minus 4y plus 3z equals 5. Look here, it goes x, y, z, x, no y's, z. Okay, now when you fill in your matrix, you're just using the coefficients. So that's 1, -4, 3, -1, 3, -1. Then our bottom row is 2, 0 for our placeholder, -4 for a z. Okay, that's just a plain matrix. An augmented matrix takes my matrix as is, and then we have a last column which represents the answers. My computer would not put a solid line there, but that's what it's supposed to be. Okay, now here we went and we put in, finish our things. So that would have been the 2 and the 0, and this time in our last column, we'd have the 6 to represent the answers. We like that because as we solve these, then that becomes what x, y, and z are in the end. Okay, these are things that you can do in a matrix. So these are operations which are legal to perform. One operation is you can interchange 2 rows. So I can take a row and change them and just switch them around. So row 2 and row 1, I want to interchange, which means I want to switch these 2 rows, which is totally fine. So I just write the 1, -4, 3 in the second row, -1, 3, -1 in the first row. Excuse me. Now, I want you to take this here, exact same matrix, and I want you to interchange row 1 and 3. Okay, pause and please do that. So now 3 becomes your first row, 2, 0, -4. Your second row stays the same. And then your third row is now what your first row would have been. I know that doesn't seem very exciting, but sometimes it's very helpful to be able to move those around. Okay, the second thing you can do is you can multiply rows by constants. So I can take any row and multiply it by a number, which means I can also multiply by fractions, which is the same as division. So I want to multiply row 2 by 2. So I'm going to take this matrix, take this second row, and multiply every number by 2. So -1 times 2 is -2. 3 times 2 is 6. -1 times 2 is -2. I would like you to take this exact same matrix right here and multiply row 3 by a -1/2. Okay, I hope you got that done well. So your first row did not change, 1, -4, 3. Your second row does not change. Your third row now becomes -1/2 times 2, -1, 0 still 0. -4 times -1/2 should have given you 2. All right, let's continue on here. Now, I can multiply a row by 2 and add it to row 3. If I do this, the only row that changes is row 3, the one I am adding to. So what you are literally doing, I'm going to get a different color up here. So I'm taking row 2 by 2, so -2, and I write the little numbers above is what I do. So that's a 2, 6, and -2. I got my negative over here. I don't actually change that row. Then I take this row, those new numbers that I just have, and I add them to row 3. So the 1, -4, 3 stays the same. The -1, 3, -1 stays the same. The only row that changes is the one I'm adding to, which is row 3. So row 3 now becomes -2 plus 2, which is 0. 6 plus 0, which is 6. -2 plus -4, which is -6. The only row that changed was row 3. Okay, I want you to practice. So I want you to multiply row 3 by -1/2 and add it to row 1. You're taking this matrix right here. Okay, when you multiplied row 3 by -1/2, should have a -1, a 0, and a 2. We're adding it to row 1, so I'm taking these numbers and I'm adding them to my first row. So the only row that is changing is row 1. So it becomes 0, -4, 5. And then the other two stay the same. Okay, if you've noticed, I have added and multiplied, correct? I cannot multiply rows together. That is illegal. It's also illegal to subtract. If you're very careful, you can do it, but it's better to multiply a row by a -1 and add it to a second. It helps you from making small mistakes. All right. Now let's show you how some of this helps us out. Maybe. Oops, that was not good. Sorry about that, guys. Just not cooperating today. There we go. Okay. We're going to use Gaussian elimination. It's the first half of Gauss-Jordan, and we will always finish it with Gauss-Jordan, but at first I wanted to get you started. Okay, in a Gaussian elimination, the first step is to get the diagonals to 1, and then everything else to the left of the diagonal is to be 0. In the Jordan part, then we change everything to the right to 0 also. 1 or 2 are done from left to right, usually starting with row 1. You can do them in any order, but you have to be careful because otherwise you start going in circles and then doing what you've done. Numbers to the right of the diagonal represent equations. Okay, here we go. So I'm going to take my equation, or my 3 equations, and I'm going to write them in Gauss and augmented matrix. So we got 1, -4, 3, 5, which came from here. Your coefficient, your next coefficients are -1, 3, -1, -3, 2, 0, -4, 6. Should recognize that one by now. Now, my goal is to get all of these to 1 and all of these to 0. The problem is I can't change all of these to 1s first. That like never works, because then as I'm trying to get these to 0, I undo my 1s. So a lot of times the way we do this is we start with the first one. So I'll start here and I'll get this guy to a 1. So this is where I'll go first. And then my second step is I'll work on this guy and try to get him to a 0, then him to a 1. And then on my last section, then I go to my bottom row and I go 0, 0, 1. All right, it's just a pattern. Sometimes it works great and sometimes it doesn't. Most of the time it works pretty well. So we're going to start here, and I need this very first part to be 1, which it already is, so I don't have to do anything. So then, since I've already got my first one as a 1, now I'm going to go down here to this -1, and I need to get it to a 0. Well, to get him to a 0, usually I can look at his column. So I look at this guy's column right here, and I'm looking at the numbers that go. So this is the guy that needs to change to a 0. Will the 1 help me get him to a 0, or will the 2 help me get him to the 0? Well, here the easiest way to do that would take the 1 and add it to here to get this to a 0. But I can't just do one column, I have to do entire rows. So I'm going to take row 1 and add it to row 2. So we're going to take row 1, add it to row 2. So 1 plus -1 is 0. -4 plus 3, -1. 3 plus -1, excuse me, is 2. 5 plus -3 is 2. All right. So we've done that. So now I've got my 1, 0. The next place I look is here. I need him to be a positive 1. Well, he's very close. He's already a -1. So I can multiply him by a -1 and get him to where I need to be. But I have to do that to the entire row. So I take this entire row times -1. So 0 stays 0. -1 becomes 1. 2 becomes -2. And this 2 becomes -2. I'm doing very well so far. I got my 1, 0, 1. So next we're going to work on this last row. I always start with the 2. I want to get him to a 0. So again, you're looking at this column. What will help me get this guy to a 0? Well, I can't do anything with 0 to get to 2 because that's just not going to help me. But I can take the 1 times the -2 and add him down. And that will get him a 0, but I have to do that to the entire row. So now we take the 1 times -2, which gives me -2. -8 times, -4 times -2 is 8. 3 times -2 is your -6. 5 times -2 is -10. And I'm going to take the red ones and add them down. Remember, the only thing that's changing is my bottom row here. So first row is the same, second row is the same. -2 plus 2 is 0. 8 plus 0 is 8. -6 plus -4 is -10. -10 plus 6 is -4. The bottom row is looking worse, but we still have our 0. So this first column is done. Now I have to go over here and I need to get rid of this 8. All right. The issue we have here is which one of these to use, because I look at this column, right? Well, the first instinct is -4. So if I take -4 times 2 and add it down, that gets that to 0. But if I take the 1 times -2 and add it down, I change that 0. So that hurts this guy. So that means my only option really to use here is the 1. So I'm going to take the 1 times -8 and add it down to this row. So we're going to have -8, 16, and 16. First row stays the same, second row stays the same. Negative 8 plus 8 is 0. 16 and negative 10 is 6. 16 and negative 4 is 12. Now I need to get this guy to a 1. He's the last one I need to change. And the easiest way to get this thing to a 1, no matter what it is to divide by it. So since this is 6, I'm going to divide by 6, or, which is the same thing as multiplying by 1/6. So that's going to change him to a 1 and the 12 to a 2. Okay, you have finished the Gaussian step of Gauss-Jordan. All right, here I'm going to show you what you have, even though we will never actually do this. These are still equations. This is x minus 4y plus 3z equals 5. This is y minus 2z minus 2 equals negative 2. This is z equals 2 right here. So as you can see, we found the z. So now we use substitution, and we'd plug 2 into here. Then we'd find y, and then we'd plug it into here to find our x. We're just using substitution all the way down. So when we go to finish solving this, we're going to work that the same way. Here we took the 2 and we plugged it in here, correct? So as we go to finish, we're going to get rid of this here next and change it to a 0. Then now we have the y and the z, so we would get rid of these two next with our substitution over here to solve for x, which is the exact same thing we're going to do with the Gauss-Jordan elimination. All right. I want you to pause and try yours. There are many, many ways to do this, just so you're aware. So I really want you to try this, and make sure you pause and go. I will show you the one I use, and it may not be what you end up with, and that is fine. Okay, I hope you did a good job. I did this one a little differently, just so you could see a different way to do it. I switched the first and the last row, so I could have a 1 at that very top corner. And then I took the top row then by a negative 1 and added it to my second to get my 0 here. Now I had all 3 here, so I divided by a negative 1/3 to get these to 1, negative 1, and negative 1. Then I took the top row times a negative 2 to get rid of this 2 down to a 0. Added that down. Then I took my middle row times 3 and added it down to get this guy to a 0, which automatically turned him to a 1. So then I was finished. Oh, this should be a 1 right here. All right, now when you're going through here, your numbers here may do differently. The only thing that has to be the same right now is this 1 and this 3. This says z equals 3. That's the only thing that has to be the same. The rest of it can be different, could be the same, depending on how you did it. And then as we finish going, the rest of them will turn out to be identical. All right, so that's the Gaussian method. So now the Gauss-Jordan is when we finish these things. So we're starting with where we left off, and now, excuse me, we want to get all of these here 3 to zeros. And we usually start with this number 2 right here. He turns to a 0, and then I'll go to my 3, and then I'll go to my 4. Is the order I usually do them in. You can do them in different orders. It doesn't matter. Just be careful not to go into zeros or into circles. So here, to get this negative 2 to 0, I have to multiply this guy by 2 and add him up. So this is 2 and 4. We add him up and we get 0 and 2. So right now we have z is 2 and y is 2. So now I have to get these 2 to zeros. And it really doesn't matter which order we do that, because I'm going to use the 1 in this row, or column, and the 1 in this column to get rid of them. So I usually just start here just because there's no preference. So we multiply by a negative 3, and we add up. So that's negative 3 and negative 6. We add that to my first row. Oh, and of course I did it with really the 4. Sorry about that. Okay, if you see here, I actually got rid of the 4 first. Don't know why I did that. Times 4, multiply up. So this is 4 and 8. So the 4 becomes a 0, and the 5 becomes a 13. Now I got to get rid of this 3, so now I'm going to multiply by the negative 3 and add up. Just negative 3, negative 6, which gives me the 0, 0, and the 7. So this tells me that x is 7, y is 2, z is 2. So this is my point that I've just found. It's the same as we did last time in substitution. Okay, now it's your turn. I rewrote the one that I wanted you to start with, and these should have been brackets. It would not type for me. Okay, I would like you to finish and see how you do. Okay, the first thing I did is I just added those 2 rows. So my first one stayed the same. My second row was 0, 1, 0, 2. My third row, 0, 0, 1, 3. Okay, now you can choose whichever one you wanted to get rid of first. Doesn't really matter. So if we just take these 2 and add them up, this guy will turn to a 0. So now we got 1, 0, 2, and 11. 0, 1, 0, 2, 0, 0, 1, 3. Now we have to get rid of that 2. And we do that by multiplying this bottom one by a negative 2 and adding up. So that's negative 2 and negative 6. We're going to add up. We're running out of room. We end up with 1, 0, 0, 5, 0, 1, 0, 2, 0, 0, 1, 3. So our answers are 5, 2, 3. So x is 5, y is 2, z is 3. And that is the point that makes all 3 of those lines, as where all 3 of those lines intersect. All right, good luck. I hope you do well on your homework. Make sure you post questions if you have any.